I've been sent this roll of LED tape and a power supply by someone who bought it on eBay, and they weren't too thrilled at the intensity of the tape. And the icing on the cake was they got a small shock off the power supply, and they asked if I could check it out. So the power supply is a 12 volt power supply, and if I put that to DC volts and we check this, yep, 12.43, which will probably fall down a bit when it's loaded. And I'm going to do an electrical test on this. First I'm going to actually measure it from the input to the output. So here's a measure. And I'll just measure it from A pin to the output. I'm not sure I'd recommend doing this to power supplies, but you know, they should be able to handle 500 volts between the input and output. So let's do the test. And it's passed that test, so let's try it on the other connection. Yep. So just out of interest, let's just reverse the polarity in case of some bizarre cheapo diode arrangement inside. And that's passed. And that's passed too, and that suggests to me that the shock that was received was probably down to RF suppression circuitry inside. And I'll just put this meter down here. You see, all switch mode power supplies, even a good quality Apple power supply, has the main switching the drive circuitry, which in the case of this power supply, it's the main side here. And it's got the output circuitry with the smoothing capacitor and the diode. And between them, for interference suppression, it's got a capacitor. In this case, it's got a very large capacitor to keep the clearance space in this good quality power supply. And that's also sleeved, which is quite interesting. And the purpose of that capacitor there is it prevents radio interference. I'm not exactly sure the science behind how it does that, but it is a sort of requirement, and it has to be what's classified as, I believe, a Class Y capacitor, rated for about 1000 volts. And the value of this capacitor is typically 1 or 2.2 nanofarad. And if you consider that 1 nanofarad has equivalent capacitive reactance of about 3.2 megohms, and then the leakage on the UK main supply is going to be about 75 microamps, and likewise the 2.2 nanofarad has an equivalent resistance, if you will, the capacitor of 1.4 megohm, and it could pass 166 microamps. And you know, it only takes about 100 microamps to, particularly at this sort of high mains voltage, if it hits you in the right place, you can get a fizz, a wee tingle off it. So let's actually do a wee test on this with a meter. So I shall plug it in, and we'll measure the voltage, AC voltage, from the output of this supply to ground. And it's showing 100 volts, which, you know, seems quite high. He did mention that he'd metered it and got about 90 volts, and it's going to be 90 to 100 volts because it will depend on the impedance of the meter, typically 10 megohms, but you're going to get round about that. So let's see what actual current is leaking here. So I'm going to turn this to microamps. Take this lead out. This is where there's a loud bang because there was a fault. And I'm going to select AC microamps and stick the probe on. And it's showing about 219 microamps, which is quite, you know, that suggests a 2.2 nanofaradish capacitor. Yeah, that's quite a modest current. And if I get the other power supplies and plug them in, here's this is this type of power supply. So I'm going to plug that in, and I'll plug in an Apple power supply. Well, let's unplug this one at the moment. Plug in an Apple one, and a cheap, dodgy Chinese one, and an as yet unopened and untested pink one. I mean, technically speaking, they're all Chinese, but this is the completely non-compliant one. This is an unknown. This has, but I've opened one of these and inspected it, and this is an Apple one, so hopefully it's good. And I'm going to test between the metal shell of the USB to ground. So I've got a ground, I'm just putting it in the solder iron here. And from the Apple, it's about 110 microamps. From the, this is from a shop called Tiger, it's 171 microamps. From the cheapy Chinese thing, it's 125, so well, pretty close. And from this one, it's 115. And if I turn that to the voltage, this will possibly indicate that some of them have better suppression than others, because there are ways to actually, the absolute minimum is to add one capacitor in, but some of them do it in another way between the supply rails that results in a lower potential voltage or current. So I have to, yeah, that's AC volts, so let's just check. So in that one, I get about 100 volts off that. From the Apple, 144 volts, which seems quite high. From this cheapy Chinese thing, 95 volts, so say 100 volts again. And from this pink thing, 47 volts, which seems actually quite low. I wonder if that's got a 1 nanofarad capacitor in it as its suppression. So another thing I thought was that those currents are quite high, so theoretically if I got a bridge rectifier and I stuck an LED in it, now I'm not sure how well this is going to show up. Let's see if it's visible. I shall shield it and hopefully you'll be able to see that's lighting, just the current flowing to earth. And if I put it into that one, it's lighting quite brightly in that one. Cheapy Chinese one, am I even getting a connection? There it goes. Oh, that's quite bright actually in that one as well. And in this pink one, dim. So this one I wonder if it's got a 1 nano. Now I've got another power supply that showed quite an odd reading. This is a dubious power supply. I wasn't too thrilled at its isolation, so I marked it as such. So let's stick that in there, and I'm not even getting a glow in that one. That's quite odd. So volts. Showing a suspiciously low, as if maybe that's just not got proper. Either it's the case, the housing is not connected to negative, or it's not got a capacitor. That's so odd. But anyway, so this is a very common type of power supply because I bought one from China recently and it looks identical. Actually, now I say that, I've just noticed this one's got a much thicker lip at the bottom. But anyway, let's open this and take a look inside, and then we shall check out the LED tape. So how is this going to come to bits? Is it glued together? Is it going to be destructive? I can see the case flexing. I don't know if that's just glued in bits or... Oh, nope, that's popped open actually. Ooh. I can see a circuit board rattling about inside. It's not that keen to come to bits, but it's got two obvious clips at that side, so I'll aim for the same positions at the other side. Try not to impale myself in the process, as usual. Maybe I can just hinge it open. Oop. It really doesn't want to open it. The clips seem quite good, although it is just clipped and not glued. Oh, there we go. So what we got That's odd. It's actually got a connector here as if it's designed to take something pluggy into it. It's got a little adjustment trimmer that could be used for setting the voltage, perhaps. How odd. Good separation, actually. It's really good. And 2 RF suppression capacitors in series. That's very odd. What value are they? Oop, helps I look at them. That they're upside down, actually, the text on them. I'm going to need to magnify this a little bit. They are classed Y2 apparently. 3.3 nanofarad. Both of them are 3.3 nanofarad and they're both in series, which gives approximately 1.5 nanofarad. This actually looks quite a decent power supply. It looks unusually good. That makes me wonder what's in, if my power supply's got the same circuitry in it. Okay, let's take a wee look at the other power supply. Guessing it opens in the same way. Actually, I'm not sure it does. Oh. Okay, completely different inside. One suppression capacitor there, with an anti-tracking slot. Again, this looks... That's a huge gap here, and it's got markings that suggest that it's a decent... It's got a pair of cut-off wires that look as though it's been cut out of another application. And the mains input wires as well. This has been repurposed from another power supply and just repackaged. Wonder why. Is it been surplus that's been intended for an application? It's even got a name. Is it Fuhua? www.fuhua-cn.com. Odd. Yeah, that's very odd. I wonder if they're just repurposing supplies then, and just to cater for the demand of good beefy 12 volt supplies. I'm not sure that's going to be 100% lock fast now, but don't worry. So I'd say the power supply is fine. The reason you get the shock was because of these capacitors here that couple the input to the output, and that does happen with this type of power supply where there's no earth pin. You do get better supplies that have the earth pin and they reference it to the output, but they're kind of specialised. This is also why sometimes in laptops when you plug in an audio lead into them, it creates a lot of buzz and hum on audio systems, because there is basically a current leaking from the live side of this, usually from after the rectifier, either the positive or the negative connection to the low voltage side. And the only way to get around that is to use an isolation transformer, audio isolation transformer. So let's take a wee look at the LED tape now. I've cut a little bit off, and I've put another bit next to it. I've put a bit of my warm white, because I prefer warm white. The cold white is a bit unpleasant colour-wise. It's okay for some applications, but it can be quite ghastly. Now, the tape I was sent is the cold white 3528 LED, just standard LEDs. They're not super bright, and it's the waterproof version. It's quite a squishy waterproof version, which I actually prefer. I think you get a sharper point with the non-waterproof version, and you also, although it's exposed, you can short things against it and things like that. It's also much easier to cut and solder because you get direct access to these solder pads. With this type, you have to try and scrape away and cut away that silicone-y, rubbery type coating before you can get access to those. So let's see, 12 volts. let's light this up and see how it looks. So that's 12 volts. So that's the... I'm not sure this is really going to show up. I'll try turning this light off. There we go, how's that? So on the camera they look pretty much similar intensity. The white's more diffused because it's got that waterproof coating, and I can see it's reflecting a lot of light back down. But looking at it subjectively, I'd say the white looks a wee bit dimmer than the warm white. The cold white looks a bit dimmer. But that might just be because some of the light is being reflected down. You can see the sort of pools where the light's bouncing off this waterproof coating. And it makes it more illuminated, the background. This tape here, I think it's white as well. Let's turn the light back on. Yep, it's not getting any light reflected back down on it. So that makes the white strip look more linear. But that is, to me, that's just typical 3528 LED. Typically run about 15-20 milliamp, and this is the sort of intensity you get. If you want the brighter tapes, you have to go for something like the 5050 LED tape, which just it has 3 chips in each position inside the one package. Or you get the other types of LED tape that have larger LEDs. But having said that, in the right applications, the 3528 is economic, and it runs at low heat, and it runs at LEDs within the rating. As you guys know, I prefer things to run cool. So I'd say the tape you were sent was okay, and I'm afraid to say the power supply, it was okay as well. It seems to have passed its tests here. It seems to be quite a well-made unit. It seems to have been maybe repurposed from some other product. Yeah. Interesting to do though, and certainly it was quite interesting for me just going through all these different power supplies and finding what sort of suppressed components they have in them.